Back in 2006, that's how old this thing is. I don't know, was anybody here for South by Southwest in like 2005, 2006, when Twitter was all the rage at South by Southwest?
Yeah.
Like that's where it kind of took off, and yeah, so Twitter started, and they had a problem. They wanted more and more people to tweet, but this was the start of the app stores and all of the mobile phone apps and everything like that. And so people were using a whole bunch of different apps to do a whole bunch of different stuff, right? And they wanted to allow people to tweet from those various applications. To say, like, if you're on your movie, like Fandango app, and you want to tweet about a movie that you just bought tickets for, they wanted to let you do that directly from the Fandango app and not have to copy the, what I'm doing, and then go to Twitter, open the Twitter app, and then do it directly in the Twitter app, okay? And so that was the goal. They wanted people to allow other apps to tweet for a user.
This time on the Plutopia Podcast, we feature a presentation about the OAUTH protocol delivered at the May meeting of EFF-Austin. Due to the visual nature of the demo portion of the session, we've posted the entire video of the OAUTH presentation on our YouTube channel. For the audio podcast, we present an edited version. Plutopia's John Lebkowsky introduced the session.
So our speaker this month is Daniel Roesler. And Daniel is the founder and CTO of Utility API, which is a clean energy software company, and they specialize in utility customer authorizations and data access. And he also has a bunch of privacy and security open source projects. And tonight, one other thing, he volunteers for the League of Women Voters and helps to make the Voters Guide. That's really important. And tonight, Daniel is here to talk about OAUTH. And OAUTH has been around for quite a while. The only thing I recall hearing a lot of stuff about OAUTH when it first came around. I knew a guy named Chris Messina who had worked on it.
Oh, yeah.
But I think, are you going to give any history of it?
Very brief.
Okay.
I would say one slide.
I think it was Twitter related,
Yep.
right? The origin
of
of it.
Twitter.
Twitter used to be this site that people would go to post really short messages. I think somebody bought it out and then failed after that. But anyway, so Daniel.
Okay.
Here we are.
Awesome. Well, thanks very much. All right, so I'm going to give an overview of OAUTH, how it works, just so that I know how to gauge the audience. How many of y'all have ever used OAuth before, like implemented against it or coded against it or anything, but you've used it in the sense that you've gotten to like click up and you click authorize and sign into your Facebook or whatever? Okay, cool. All right, well, we're gonna dive into how the protocol actually works, why it works that way, what the trade-offs are, and then we're actually gonna develop an implementation against GitHub's OAuth. So you're gonna actually see it work tonight. And I will be fumbling along trying to make it work, so we're going to troubleshoot it live if it breaks. So, okay, so to start off with, back in 2006, that's how old this thing is. I don't know, was anybody here for South by Southwest in like 2005, 2006, when Twitter was all the rage at South by Southwest?
Yeah.
Like that's where it kind of took off, and yeah, so Twitter started. And they had a problem. They wanted more and more people to tweet. But this was the start of the app stores and all of the mobile phone apps and everything like that. And so people were using a whole bunch of different apps to do a whole bunch of different stuff, right? And they wanted to allow people to tweet from those various applications. To say, like, if you're on your movie, like Fandango app, and you want to tweet about a movie that you just bought tickets for, they wanted to let you do that directly from the Fandango app and not have to copy the, what I'm doing, and then go to Twitter, open the Twitter app, and then do it directly in the Twitter app, okay? And so that was the goal. They wanted people to allow other apps to tweet for a user. and like directly from those apps. The problem was, how could you actually technically pull that off, right? What was the mechanism and the protocols and all of that sort of stuff that you could do? Because at the time, like interoperability between various apps and allowing users to do things from one app in another app was kind of a new thing. And so they searched around, they couldn't really find anything, but they tried they looked at a whole bunch of different stuff. So how would Twitter allow other apps access, access to post as users? So that's where it kind of started from, was that main problem. Okay, so option one, easiest option, just share the login credentials. My Fandango app, or like just let Fandango collect the Twitter login credentials for a Twitter user, and then just use those login credentials. And so this is like the classic slide that they have on Wikipedia for like how OAuth kind of was formed. So you take, you got your user, the user has a login, an email and password, and then it goes in and it gives that login to a third-party app, so the Fandango app, and then the Fandango app goes through and just logs in just straight up, either through a scraper or you offer an API endpoint or something like that, just straight up logs in as the user, impersonates the user, and then posts the tweet. Well, that's not ideal because the third party sees the login credentials. You can effectively impersonate the user in that sort of case. And so it enables that third-party application to have a lot of power with that user, right? So that's not great, but that was one way you could do it.
Also, usually doesn't work very well if you have 2FA, in my experience.
Exactly. So 2FA, well, this is way before 2FA kind of really took off. So.
But that's just something I've noticed, is usually if you have 2FA, that method doesn't hold up very well.
So
you have to pick between that
and also if the user changes their password, all of a sudden you lose access and all that sort of stuff, right? So, and if you have the login credentials in general, you can go in and change the password. So now the third party has effectively taken over the account potentially, right? So that's not ideal. That's option one. Don't like option one. Option two is just trust the third party application. Okay, so here is like the user says, I want you to tweet hello world, and my username or my Twitter handle is this, gives that to the third-party application. Third-party application tells Twitter, says, hey, EFF Talk told me to tweet hello world, please do that. And Twitter says, all right, we trust you. You Pinky's promise that we're gonna, the user told you to do this, you're a trusted third party, and so we're just gonna let you do it. And so this is another method where you just require trust of the third-party application. Well, that's not so great because third-party applications can lie. They can lie and say, oh yeah, we totally got that user's permission to do it, but there's no way that Twitter can actually verify that, okay? So that's the second method. It's not ideal. Fun fact, this is actually how retailers work in Texas when you want to change your electric provider, is this method. It's hilarious. So if you are outside of Austin, you know how Texas is deregulated? You can, switch your energy provider. If you go to another energy provider and say, hey, I want to buy my energy from you and not this other one, they straight up tell the Texas grid, hey, this person told me to switch their account to my account, go ahead and do it. And Texas is like, okay. And so it's called a warrant process, where you warrant that you're telling the truth and you back it up through insurance and random audits and stuff like that. But that's how the Texas grid works on the deregulated side. It's hilarious.
Can't wait to read about that on KXAN.
Right? Well, that's the thing. That's one of the reasons. It's just retailers is kind of a very, I don't know. It's a very competitive market. Anyway, so back to Twitter. Twitter's I don't know about this. I don't trust Fandango. There's going to be so many apps out there. The App Store has thousands and thousands of apps. It'll eventually have millions of apps. We want all those apps to be able to tweet things. but we don't have to vet them. We don't have to have individual contracts with them. We don't have to trust them. So like this is not scalable to be able to trust that. Okay? Any questions on the option 2 or I guess option 1? Okay. Option 3, come up with something new. Why not? You're a tech company. Come up with something new. So this is what they came up with. Wow, that's complicated. Okay, so we're gonna break it down, but that's effectively what they came up with. Okay, so let's talk about it. There are 9 steps in this, but you can kind of break them out into a series of categories of steps. So first off, you say, okay, so this is the user over here. This is the just user on their phone. This is third-party application, so that's going to be Fandango. So you say, hey, tweet this, hello world. Third-party application says, okay, now you need to go to Twitter to get a token. So this is called the 302 redirect. So it goes to Twitter. Twitter responds with a pop-up that says, hey, do you want to allow this user to tweet, or allow Fandango to tweet for you? You say, yes, I want to allow them. And it says, okay, give them this authorization code, and it goes back to the third-party application. So this is the same app, it's just 2 different URLs. You get that code, you pass it to your server, server says, here's the code, you come back, you get the token, and then you use that token to say tweet, and then it tweeted, and you tell the user you tweet. So to the user, it's tweet this, they get a pop-up saying, do you want to allow this to tweet? Do you want to allow Fandango to tweet? And then you get a tweeted. Okay, so it's a very, very simple flow for the user, but there's a lot of handshaking that goes on in the back end. Okay? So I'm going to break this out. So it basically goes into 4 categories. You got this first one, second one, third one, fourth one. Okay, there's 4 basic steps to OAuth, which are listed here. Okay, so the first step is called an authorization request. Hey, Twitter, I want to request access to this user's account so I can post tweets as them. That's the first third-party request for a user to authorize access. And that was this first one. Hey, do you want this app to tweet for you? Okay, so that's that first step. Second one is authorization response. So that is when the user actually hits authorize, what happens? What happens is Twitter issues an authorization code. They say, hey, this is your code, that is your receipt, effectively, that you can turn into the Fandango app, and the Fandango app can then use that to issue an access token. Okay? And we'll talk about why you just don't straight up issue an access token right away and give it to the user. Okay? The third is a token request. So you take that code, that authorization code or that authorization receipt code, and then you hand it as a third-party application. So Fandango says, hey, here's this receipt code that I got. Issue me my access token, please. So that's that token request, and they get back, they convert that front-end code to a back-end access token, right? And so Fandango knows this access token, the user does not. And we'll talk about why that is in a second. And then the last step is to use the access token to do things, like to actually tweet, to actually say, hey, this is what I did, okay? So that's where these kind of 4 go down, is you request, you authorize, you issue the access token, and then you do things with the access token, okay? Those are the basic steps of OAuth. I want to pause there. I went through that pretty quickly. But functionally, like that pop-up that you see with the authorize, and then it pops back in, this is the handshake that is going on behind the scenes. Okay?
And it's not a blanket authorization, right?
No, we're going to get there. Yeah, exactly. So
I have a question that you might get to later.
Yeah.
Other than the fact, and I know this from experience, when the access token only allows certain actions, right? Like
Correct.
tweeting, for example.
Yep.
So other than that, how is this superior to method 2 where it just trusts the app?
Right.
Are you going to get to that?
Yeah.
Okay.
Well, I can explain it right now. We might as well dive into that right now. So why is this good? So the difference between this, where you're just trusting the third-party app, is the user never interacts with Twitter. The user just tells the third-party app, and the third-party app then proxies that over to Twitter. So Twitter has no idea whether or not the app is faking it, or whether or not, like they could just be impersonating the user and saying, hey, the user told me to do this, I promise they did, when they actually didn't, right? With this method, Twitter actually interacts directly with the user. There is a pop-up, and the pop-up comes from Twitter, and Twitter asks the user, do you want to do this? Okay. And so Twitter is confirming directly with the user and doesn't have to trust the third-party application to promise that the user is asking for this.
Gotcha.
Okay? The trade-off is that Twitter actually has to make that interface, right? And so that's the trade-off, is any application that wants to offer OAuth authorization implementations, they have to build something, they have to offer it, right? So when we get to GitHub, GitHub has documentation and an OAuth endpoint and all that sort of stuff, so they can actually like prove that they're doing it, okay? Okay. So that's the big difference, is you don't have to trust, like when we get to the benefits at the end, you don't have to trust the third-party application because you directly confirm with the user, hey, did you authorize this? Or like, do you want to authorize this?
Kind of like an out-of-band confirmation.
Exactly.
Okay.
Yeah,
cool.
yeah. So
okay.
we'll get to, like, at the end, we talk about, like, there's many extensions to the OAuth standard. And so you can, for example, like if you ever tried to use a Roku or something like that on your TV and it's like, go to this URL and type in this code, that's called the device code flow for OAuth, and it's basically OAuth if you don't have a keyboard, like on a TV or something like that. So there's a bunch of extensions that handle those sort of scenarios to do that sort of out-of-band authorization. But you're going to the actual website, like Twitter, instead of just directly interfacing with the third-party application.
Right. Got it.
Okay? That's the main advantage. And the other advantage is that in this flow here, where the user is directly interacting with Twitter, that's where they log in. So they're logging in directly to Twitter. They're not passing login credentials to the third-party application. So there's no login credential sharing that's needed. So that's why it's better than option 1.
How do they know the pop-up came from Twitter?
How do they know the pop-up came from Twitter? That is a great question. We could probably go into it in Q&A. That's a little bit, so that gets into the like security considerations, that sort of thing. The short answer is that the access token just wouldn't work if it weren't from Twitter, right? Twitter is the one that issues the authorization codes. And so if you have an intercepted, so say you're on an app, and you're 302 redirecting to Twitter, right? And you get intercepted right here. If you get intercepted right here and move to some other application, it'll issue that access token, right? Or a fake authorization code. The problem is when that third-party app gets that authorization code and hands it directly to Twitter, because this is the third-party application server, right? Not the front-end application. Here's the code, it won't work. Right? Because it wasn't Twitter that issued that access code. So the system will just break down and you'll never get this far.
But they have to log into Twitter before they start on Fandango.
They don't have to log into Twitter before they start on Fandango. In this process, you can say on step 3, if you're not already logged into Twitter, you can actually, on step 3, ask the user to log in.
Okay.
You say, hey, not only do I want to ask you for this permission, I also want you to log into your Twitter account. You can, if you're already logged in on your Twitter app, it'll skip that, right? Because it already knows you're already logged in. But if you're not logged in, it'll still ask you to log in. Yep. Okay, so that's why this is better than option 1 and option 2, despite its massive increase in number of steps. Okay, any questions? Looking at the thing.
Yeah, ignore me.
Okay.
Power doesn't seem to be working.
Oh no. Okay. So let's go through what these actually look like. So an authorization request is a HTTP request. It is a URL like twitter.com/authorize with a series of parameters on it. And so these parameters define what exactly you're requesting. Okay? The first one is a client ID. So client ID is the identifier for the app that's requesting. So a client is the app that's requesting the access. So it's going to be the Fandango app. So this is Fandango apps. App 123 is the client ID. The second thing that you need is called the scope. And we talked a little bit about that earlier. The scope is the level of access that you're requesting. What are you actually requesting access to? And so let's say that scope here is allowing people to tweet. So tweet please. And you can ask for access to other things, like I want to get my followers list, or I want to get the email of the user. When we get into the GitHub thing, we're going to request 2 different things that we want access to. We want to be able to read a public key, and we want to read the email of the user. So those are going to be the scope of the authorization. That's what you're requesting access to. Okay? So when Twitter gets this, it knows what to present the user. Hey, do you want to authorize these things as far as access? Okay? Questions? Okay. Second thing, authorization response. So this is once the user clicks authorize, it will send a request back to the application. And so this doesn't have to be, it's a URI. So if you're in mobile development land, you don't have to put HTTP in front of your, URL. You can put things like Uber : / and that's the Uber. It'll redirect to the Uber app with this URL or URI, right? And so you don't necessarily. It can work in the web. It also can work in applications, mobile apps. So you want to redirect to the My App for their specified redirect endpoint, which we'll get into on the demo. And then it has a code. The code is your receipt token that you turn in at the end. Okay? And so that is what the app gets. It gets a code back. And I'll talk about state parameters during the demo, but let's leave that out. Actually, no, I'm going to talk about that right now. So there are optional parameters you can add to these that allow you to track between the authorization request and the authorization response. You can imagine if you're running a website and you're sending authorization requests, redirecting users to Twitter, and you have 50 users who you've redirected to Twitter, and they come back with 50 codes, how do you know which user is for which code that you sent to Twitter? Because remember, you're sending the users to Twitter, they're authorizing, and then they're coming back. And so there's an optional parameter called a state parameter that allows you to specify some code that then will be returned along with this code. So that'll allow you to track, oh, this request belongs to this code, which we'll show you in the demo. Okay, so once you actually get that code, this is where that, just to recap. So we get this code, third-party application has it. Then it sends that code to its own server here. That server is hosted somewhere. It's not on the mobile app, right? Which means that it can contain secret information. So each of these third-party applications that are registered with Twitter are issued a client ID, which is part of that initial request, and a client secret. That client secret is not on the mobile app. It's on the server. And so when it gets that code, it adds both that code that it got, it adds the client ID that it was originally requested for, and then it also adds the client secret that only that server knows. Okay? And so that means that Twitter knows, oh, this is this third party who's requested this. So this code, when paired with this client secret, is a combination where I can issue an access token. So that's the combo that Twitter needs in order to be able to do that. And then the response to that request is the access token. The access token says, hey, this is the access token you can use on the API. And then the last step is to actually use the API, and like every single service that offers OAuth has a different set of APIs. Twitter allows you to tweet and to see your followers. Well, I guess they shut down their API because there's nobody maintaining it anymore. But GitHub offers access to repositories and user accounts and like GitHub issues and stuff like that, pull requests. So like every API is going to offer a different thing. But you use that access token, so your Twitter, please use this access token and post the message, hello world, and success is true. Hooray, we tweeted. Okay? So those are the actual requests that we're going to do. All right, so let's try it out. Let's actually go, is it worth it? Yes, it is totally worth it. Here are the awesome things about OAuth. There's no more login credential sharing, so that was option 1. It doesn't require trusting the third-party apps, so that's option 2. Twitter directly verifies the user authentication and consent. And lastly, it can be embedded in apps and websites for seamless user experience. So it's a pop-up, pop back in, you're still in the Fandango app. Okay? So click button in the app, pop out, authorize, pop back in. Any questions before we start moving around with code?
Do you only authorize once, or can it expire?
It can expire. And if you're, this request down here indicates whether or not it was a success or not. So if, for example, you get an access token, and we're not going to go into refresh tokens and expirations for all that sort of stuff tonight, but for now, just assume the access token is good for, I don't know, an hour, and then you go in the next day and you want to tweet about something else, it's up to this request to return an error saying that access token is no longer valid, in which case you just kick the user back into authorize again. Another pop-up, authorize, get a new access token, right? Because it's just a pop out, pop back in process, you can just reissue authorizations as much as you want.
And expiration can be any duration, or you don't have
That is up to
expiration?
Twitter.
Okay.
Yeah, it's up to the authorization server, which is Twitter in this case, to determine management of how long access tokens last. Usually things last for an hour and then either they give you a refresh token, which is another token in here, which is this ... and you use that to issue new access tokens, which is kind of convoluted and I don't know, it's not ideal. But there's a way of getting perpetual access for long-term stuff, but some authorization servers don't even do that. They just say, go ask the user every time. Cool. Questions? That was a very speedy overview of the OAuth protocol. All right, let's make an OAuth app. All right, so I'm actually going to bring up.
Can a web browser be an app?
Yes, exactly. A web browser can be an app, and we're going to do that in a web browser. We're not going to do it in an app. So yeah. So if you've ever seen the sign in with Facebook or sign in with Google buttons on the login, that actually uses this handshake. And instead of down here saying tweet, it actually says, give me the user info. And this process called OpenID Connect. And so OpenID Connect basically follows this same exact process, except down here, instead of tweeting, it says give me the user info. And that is what the server says, okay, that's that user, I'm gonna log you in as that user.
You using the SSO as an example just made so many things click in my head.
Oh, Okay.
Just like
You
things
wanna
I've always
expand on
wondered.
that?
Well,
Like
just
what-
things I've always wondered, like if it's safe to use, because like I'm
Yeah.
paranoid and I don't trust Facebook. That's
Yeah.
just one example.
Yeah.
But so I've always wondered, like how does that work where it's supposed to be more secure, but
Yeah.
but now I see the other risks where like who knows what that is requesting in the process besides just authorization. I don't know. It just
Well,
made a lot
so
of things
the
make sense. to me.
scope up here
Yeah,
would
right.
be OpenID Connect or single sign-on. It would, and so down here, it would give you access to the user info API
Mhm.
to get like the user's username and their email, but not anything else, not like your Facebook posts. I mean, it could
Well,
have.
yeah, on their end, yeah.
Yeah.
Really give
So
that-
the downside, yeah.
Twitter would really give that information out to the
Yeah.
third party?
If the user wants it to, the user clicked authorize. Boop. Like tonight, I'm gonna share my email with myself.
You madman.
I'm mad, man. Yeah, because Facebook wants, so the downside to single sign-on, the login with Facebook, the login with Google, right, is that the app that is the My App that is using that single sign-on is trusting the authentication of the user to Facebook and to Google. And so they are now dependent on Facebook and Google, right? So if Google goes down, a user can't log in.
Oh.
And so you're delegating responsibility of authentication to that third-party provider. And so Okta is another example of that. That's like a corporate single sign-on provider. And so you are, as a enterprise, delegating your login to, or if you've ever seen like sign in with Microsoft or whatever, you're delegating that responsibility of authenticating the user to that centralized provider. And so this is like, this sort of single sign-on stuff is starting to replace your, like your other corporate identity providers. Like, what is that? LDAP? I don't know. Whatever the Windows authentication stuff
But
is.
it still requires, it
SAML.
still requires you to share your main login that you use with everything.
Yeah.
With each app.
Yes.
But they don't
Wait,
do
no,
actual
no.
credentials, which is one of the things that just
They
clicked
just
for
do
me.
it.
So they don't see your Facebook password. They just ping Facebook for that, like, hey, is this cool? And then Facebook goes to you and says, hey, is this okay?
They just get the token.
They just
Yeah.
get the token. That's one of the things that clicked for me just now, because I had that same thought. I'm like, aren't they sharing your credentials with everybody? And apparently not.
No.
So,
Okay. This is why this is the most widely used authorization protocol. Because fundamentally, it's just an, hey, do you authorize this? Okay, here's a token. Yeah.
Is this, how does OAuth 2 relate to this? Is this OAuth?
This is OAuth 2.
Okay.
So OAuth 1 was Twitter's initial thing, and it involved like signing requests. It was pretty complicated. And so they were like, no, screw that. We're going to simplify this. And they tried to simplify it, but then there was a bunch of corporate stuff that was thrown in to make it more complex. So I'm erasing all of that for this talk and just going with the bare bones OAuth 2.0. Okay. Yeah? Any other questions? Ready to start coding? See me, watch me sign up for some GitHub accounts? All right, so I'm going to sign up for 2 GitHub accounts. Let's see if I can do this while also talking, and I guess I should have been doing this while I answered questions. So you're just going to actually watch me do this. And my email. So on the right or left side, I'm going to be the, actually I'm going to change this to user. I'm going to be the user. Password. Just going to be the same user. Would I like to receive product updates? No, I would not. Verify account. Oh, we're going to do a CAPTCHA. Here, somebody help me. We're going to put that. That. Did I get it?
That's a tough puzzle.
Right?
they really are getting hard these days.
Create an account. Oh, I gotta get my code.
I can identify some persons.
Right?
Maybe one.
Wait for my code.
This is your reality.
Twitter code. Paste it in here. How many team members? Just me. Can I skip all this? Skip personalization. Ooh, wow. Okay, so this is on the left side, that's going to be the user who has a GitHub account, right? So I'm going to go here and I'm going to open up my settings, and I'm going to upload a public key I have generated just to make things GPG keys. And GPG key. Paste. Key. Add. Did it work? Yeah. Okay. So I have my user here. All my repos, I haven't done anything, and so then I'm going to do the same thing on the other side, and I'm going to do they make this thing so clever, but it just takes a while. Username. So this is going to be the Fandango app, or the application. So it's going to be EFF Talk app. Okay. Oh, here we go. Another puzzle. That one. Two identical objects, right? Oh, I feel like this is like the, what's the name of the Among Us sort of?
I thought that too.
Kind of feels like that. Create an account. Maybe get my Oh, yeah, the Where's Waldo? Yeah, there you go. Wait for this to come in. I have a wild card on this domain, so any email that I just make up gets forwarded to me. Okay, paste this in here. Can I skip? Skip. All right, so left side, user, right side, application. So on the application, the first thing I'm going to do is I'm going to go to my settings, and I'm going to create a client ID in secret. Because I'm the application, that's what I need to do. I need to create a client ID in secret. I'm going to go down to the very bottom. There's a thing called developer settings. There's a thing called OAuth apps. I can register a new application. So this is my Fandango app equivalent, right? So I'm going to do the app. Talk app. EFF-Austin.org. Okay, so this is the callback URL. So this is the redirect URI where we want, going back to the presentation, this is where we redirect the user and the authorization response. Okay? So I'm going to go into here. I'm going to say HTTPS. Let's just do EFF-Austin.org/redirect. Sure. And device code flow is the TV mode one where you can log in without a keyboard on your TV. But we're not going to do that. All right, so I register the application. Okay. So client secrets, generate a new client secret. I have my client ID. And let me copy my client secret. So I'm going to bring up another window. Client secret and client ID. All right. Okay. So I have a browser here, over down here. I have my client ID and secret. Let me get rid of this view side panel. No. Okay. So I have my client ID and my client secret. I'm going to raise that up here. And then I'm going to open up the terminal window. Put it down here. Okay. So my client ID and client secret. Hooray, I have registered an application. Now I need to actually make a authorization request. So back on the top, authorization request is the first thing. So I go to this, in this case, it's going to be github.com. It's going to have an authorization URL. It's going to have a client ID. It's going to have a scope. So let's actually do that. Okay, so I already have that down here. All right. Let's full screen this. Okay. So I have my github.com/login/OAuth/authorize. I have my client ID. All right, I'm going to go up and copy it. Paste it in here. All right, so I have a scope. I want to get access to the user's email and be able to read their GPG public key. That's what my scope that I'm requesting. Then afterwards, I want to redirect to that place that I told it to, EFF-Austin.org/redirect. And then I'm going to be able to track the user through that authorization request by giving it a state parameter of just all nines. Okay, so when it comes back to me, it should have that state parameter so I know where that user came from. Okay? I'm going to go ahead and open that up. Over here. And wrong one. This one. Okay. So I'm logged in as this user over here. It's a completely different browser window. I'm in incognito mode compared to the main window, so completely different session. Logged in as that main user. If I open up a tab and I go to that URL, which is the scroll left. Can y'all read that? Is it too?
Yes.
Yeah.
So I'm going to github.com/login/OAuth-authorize. It detects that I'm already logged in as that user, and it presents me with this authorization form. This authorization form is saying EFF-Austin Talk app, by EFF-Austin app, of course, wants to access your, and this is my user account, and it says read access to your GPG keys and personal user data, email addresses. This wants to see my email address, and it wants to see my GPG key. If I were to edit this URL and request something different, let me paste in a new one and say, I don't know, remove the email, so I can just remove that. If I were to copy this URL, it would only say, GPG keys. And so you can customize what you're requesting access to based on the parameters of that request. Okay?
And GitHub had to implement that front end that
Yeah.
displays nice GPG keys and
Exactly.
scope to whatever's displaying.
Exactly. So it has to dynamically generate this authorization based on the URL parameters that I'm providing. Okay, so GitHub did implement this. It's on GitHub's domain. And it knows who I am, EFF Talk user, because it's on GitHub's domain. My session cookie is still valid. I'm still logged in as my GitHub user. Okay? So I'm just going to go ahead and do the first one, though. Get access to both. Okay. And so I can cancel or authorize access. So this is that pop-up where you authorize access. So I'm going to go ahead and authorize. And then it says redirecting to the EFF-Austin. Oh, of course, the redirect URL doesn't actually exist on EFF-Austin's website, but this is where it redirects to. Let me full screen this real quick. EFF-Austin, and it redirects with an authorization code, and then that state parameter that I set previously, so I know where it came from. Okay? So I can copy this code. I'm going to put it down in here. And then the next step is this, okay, token request. So we've done this, we've got our code. The next step is a token request where I'm saying, okay, GitHub, here's my code, here's my client ID, here's my client secret. So that request is a backend request. And so if you've ever used curl before, this is basically a way to create requests on demand on a command line. And so I'm going to go up and I'm going to copy my client ID and secret. So weird, like looking back at this. And I'm going to open up the terminal. Okay. So I'm going to set these as my environmental variables. Yes, unsafe paste, I know. Okay, so I've set those in my command line, and then I'm going to make a request that has the parameters of client ID, client secret, code, and then redirect URI of EFF-Austin.org/redirect, and I'm making that request to github.com/OAuth/access token. Okay, so that's that converting that code to a, I'm going to copy that, paste that, please work. Yay, it worked. Okay, so the response back that I get looks like this. Let me full screen this again. Okay, so I get a access token, and then I get a token type bearer, and I get the scope that was authorized. So some OAuth providers let users modify, like uncheck things that they want. And so this gives you an opportunity as a server, as the app, gives you an opportunity to see what the user authorized. So these are the things that the user authorized. Okay? Cool, I got my access token now. So I'm gonna put that access token in here. And then I'm gonna actually start to request things. And so here I'm going to request access, oh shoot, hang on. I think I need to fix something right quick. One second. There we go. Okay. So I got my access token. Then I have two API endpoints. So this is like getting my user emails, api.github.com, and then getting the user GPG keys. So let's go ahead and request that. Actually, I need to do this. I'm going to drag this over on the side here so I can see them side by side. So this is the user emails. Clear. Yes. Enter. There. Access token. And then I can copy this user. All right, so if I paste this, so I am requesting the user's emails given that access token that I got from this OAuth handshake. When I request that, I get back a payload that is EFF talk user. Boom. Successfully got the user's email using OAuth, never saw the user's login credentials. It was embedded within the application, and I did it all in, what, 15 minutes? So that's how easy it is to use OAuth, folks. Everybody's all complaining about how bad OAuth is, that sort of thing. Here it is, I just did it. Okay? So there. Deal with it. Okay. And then next, say I want to get that the other thing that was authorized, the GPG keys. Same thing, it's just a different API endpoint, but you use the same access token because that access token is allowed to access multiple things. And so if I do the same thing here, it's that, I get my public key. So begin PGP public key block. Hooray! Okay. And so that is how you use OAuth to request data from users and then get access to it. Okay? I can show a little bit about some cool things. So first off, I'm going to go to my user, back to my user. Now if I go to my settings, So remember, this is the user. Go to my settings. Down here in your settings, there's an integrations applications. If I go to my applications, I can see authorized OAuth apps. If I go here, I can see, oh, I have authorized this app. And I can see what permissions I gave it. Let me full screen this. I can see what permissions I gave it, and I can revoke access. I'm going to go ahead and revoke access. So then, if I go back and I try again with that access token, same thing, I will get bad credentials. So I'll get a, what response is this? 401 response. So that indicates that I can no longer, I have been revoked from accessing the account. So the user is still in control of that. Additionally, if I go back and I request another, where is it? Here. Nope. Go back and I just do that URL that just requests the GPG key. And I authorize that one for this user. So I'm just doing authorized access. And I'm going to have to go through this whole thing again. Code, right here. Paste the code, copy the code, code from here, copy this. Token. Obviously, you script all this. Access token. Access token. So this access token is only allowed to see the GPG key. And I use that access token. I will be able to make this request. So I can get my public key, but I won't be able to get emails. Because I was not authorized to access emails. If I make that request, I'll get a 404 not found. Okay, so that allows you to customize what you can and can't have access to, and GitHub can roll out limited access on. And this is not just read, you can write access to. You can allow an application to post a GitHub issue, or to, file a pull request for you, or to do whatever. And so there's a bunch of apps on the marketplace that allow you to do that sort of stuff. Okay.
How much of this is done by GitHub?
So all of these requests are APIs that GitHub runs. But I'm just using GitHub as an example. GitHub doesn't run all OAuth apps.
Right.
So Twitter runs their own, GitHub runs their own, Facebook runs their own, any sort of like Microsoft runs their own. They're not all running on GitHub.
Okay.
Yep. This is just to allow access to GitHub's features and functionality, the repos, the GitHub issues, the pull requests, the projects.
What if you've got a request with two things, you only authorize for one?
You would only get that in this response that the app gets back. It would only see that one thing in the scope that was authorized. So if you requested two things and the user only authorized one, GitHub doesn't allow that. GitHub is like an all or nothing thing. You can just decline it. So actually, let me show that real quick. If I decline an authorization, I'm going to have to, where's my, so if I request a access to the GPG key, say, and I paste it, and then I say cancel, say, no, screw you, I don't want to do it, it'll still redirect you back to EFF-Austin, but instead of an access code or an authorization code in the URL parameters, it will give you a Error. Access denied. And so it'll tell you when a user has denied the authorization request. So you pop up, user denies, comes back in, and then it's up to you as the application to, I don't know, do something else. Have a fallback procedure or something else like that, right? Say, oh, we encountered, like it doesn't look like you authorized, we need you to authorize. So it's up to the application developer to handle this sort of a thing. Okay? Okay, so that's the demo. Any questions on the demo? Seems like we went through it pretty extensively. Hopefully this was super informative or mildly entertaining or just really boring. I don't know. All right, so is it worth it? We already went through this. Again, awesome thing about OAuth is there's no login credential sharing. Doesn't require you trusting third-party applications. Like GitHub doesn't trust me. I just registered those accounts right now. All it takes is the user trusting you, because the user is the one clicking authorize. And I obviously trust myself because I registered both accounts. And it's easily embedded in applications. So I could have a button on the EFF-Austin website that goes to that request and then comes back to EFF-Austin, and I handle that request. So a user can always start on EFF-Austin.org and come back to EFF-Austin.org after they're done authorizing. So it's really nice to be embedded in a lot of different applications. Okay, resources. OAuth.net is the official thing. The official specification is governed by the IETF, the Internet Engineering Task Force. The original one is RFC 6749. There's a bunch of extensions, but that's the original official specification for OAuth 2.0, which is the one that we did tonight. They are in the middle of making an OAuth 2.1, which is backwards compatible, and it has a bunch of additional security features that help guard against things like man-in-the-middle attacks, that sort of thing, but we're not going to get into that tonight. But the example docs, we have the GitHub one, which is the guide that I used to create tonight's demo. Also, my company does. We have our own authorization service for getting access to customer utility data. So if you are a utility and you want to offer access to, say, your smart meter intervals, that sort of thing, you can basically hire us and we'll build one of these for you and use OAuth to allow users to be able to share data with like a solar company or an energy efficiency company, that sort of thing, like your Tesla app. You can use OAuth to do that. So shameless plug there as well. Okay, but wait, there's more! So there's a ton of extensions. I'm gonna actually load this page up and let you see how many damn extensions there are. So all the specs. Jeez, oh my god, so many specs. A lot of specs. That's the original one there, at the very bottom. But there's a ton of stuff that do a ton of other things. So, like, how can apps discover which services are available? Like, how do you know that GitHub offers an OAuth service? How do you know that Twitter does? How do you know that Microsoft does? Well, there's specification for that, where a server can basically advertise, hey, you can use OAuth with me. And also it allows for dynamic registration of apps. So yeah, I don't have to manually click through and go to my settings and create an app. So those are some extensions there. How can users authorize if they don't have access to a keyboard? We talked about that. You know, if you're seeing on your login into your Roku, it says go to amazon.com/device and then type in the code that you see on the screen. That is called the device authorization grant that allows you to grant access to things that don't necessarily have keyboards. How can we use public keys instead of client secrets? Like client secrets are just like strings that can be leaked and that sort of thing. What if you want to use a hardware security module in order to provide access? Well, that can use a JSON web token that can sign the individual request. That's another extension. So there's a lot of extensions on extensions for OAuth. It's been like, that's probably where a lot of people get lost. Is they're like, oh my God, which one of these do I need to do? Well, it's so complicated, that sort of thing. But like, the bare bones basic is as simple as what we did tonight. Okay. Thanks. I think that was about an hour, so really short presentation for EFF-Austin. We can talk about questions or anything like that, but thanks everybody for sticking it out and watching the demo. Okay, yeah.
Can you talk about some of the security concerns about maybe OAUTH grants that were scopes that were granted and then maybe left behind and never revoked? Like, is there a scenario where they never time out? What about like mishandling a state and things like that?
Yes. So for abandoned grants, there is actually a spec. Hang on. So there's two ways to revoke a grant. So a grant is basically an issuance of an access token. There is a specification where a client can revoke token revocation. That's RFC 7009. So that's basically the Fandango app can say, hey, I have this grant, go ahead and revoke it. This user left my system. So they can proactively revoke it. In addition to that,
That would be, you said client, so that would be like if I signed out of the app on my phone or something.
that is the app itself. Sorry, in OAuth terms, a client is an app.
Right. I'm just making sure
But
I understand.
conversely, a user over here.
So like I'm Fandango, the client shut down their account. I'm gonna go ahead and revoke that grant on their behalf.
Yeah,
Gotcha.
on their
Okay.
behalf, because
Gotcha.
I don't want it lingering around. If I
Right.
get hacked, I don't want to incur the liability for it or anything like that. In addition to that, pretty much all of the implementations of OAuth there is will have an ability to revoke from the user's settings. So here, if I go to my authorized OAuth apps, I don't have any authorized applications because I clicked, decline when we did our example previously. If I were to grant access here, I would be able to see and revoke it here. Most, like if you sign into your Google and you go to your Google account, you can see your connected apps, that sort of thing, for what you're allowing access to. And so you can revoke independent of your application. You can just go directly to your GitHub account and revoke access within that. So those are the two ways you can revoke access for stale grants. The second thing was state stuff, I think.
I mean, I'm just wondering, like,
Yeah,
if that never gets revoked, like, let's say I work for a company.
yeah,
I authorize an app to, steal my children, because I don't care.
Sure.
Use grants like we can be. And then I leave the company, and then the IT department, they never clean that up. That's kind of what I'm getting at.
So in that case, that would be an instance where, if your EFF user has granted access, there would be a grant. Why don't I just add a grant here right quick? No, might as well. Weird. Add a grant there.
Because what I've seen, if it's their Gmail, and it's their personal Gmail, and they've got, pictures of their kids or something, they're gonna care, but if it's Acme Corp and it's
Yeah.
not their company, I don't really care.
Yeah, that is a good point. It is up to the user to manage their own grants. GitHub's not going to know.
Right.
And so it's up to whoever the organization is to manage their users' grants and know what they are. But one of the things that if you close down, so for example, the way that that's governed generally on corporate accounts is within a corporate account. So say you have a GitHub organization, and that GitHub organization has a bunch of private repos that you're pushing code to, all that sort of stuff. When somebody leaves, what you will do is you will revoke that user from the organization, and when that happens, whatever grants they had given is attached to the user. And so the user's grants go bye-bye along with the user from access to the repo. And so it's just you attach your grants to a user, not to an organization. That's the way that that's kind of governed usually.
So when users flush, the grants are flushed.
Exactly.
But if the users never flush.
Well, that's your own,
That's your own damn fault.
that's your own damn fault at that point.
100%.
Right. And And so like back on here, go to my authorized apps.
So if I ever have to
Right.
randomly reauthorize the OAuth, it means someone got fired.
Sure, exactly. Okay, so other stuff, yeah.
So you're talking a lot about why OAuth is so good. What are some ways that it's bad? Or,
Yeah.
like, or are there any like common vulnerabilities? Maybe like,
Yeah.
or like favorite vulnerabilities that you know?
So the bad thing about OAuth is it is a specification, not a certification. So it's a reference document, right, an RFC, a request for comment, and anybody can implement it. It's just out there, you can implement it, you can reference it, etc. And you can tell anybody, hey, I offer an OAuth implementation. But there's no check to see whether or not you implemented it correctly. And so what has ended up happening, and why everybody doesn't, or not everybody, I love OAuth, why a lot of people don't like OAuth, is because there's been so many applications, like, okay, so GitHub, for example, doesn't allow you to use your client ID in secret in a authorization header. It requires you to have it be a part of the post body for the token request, right? But Google does the opposite, where it requires you to have a header for your client ID in secret instead of in the post body. And so you can't use a unified library across a whole bunch of different OAuth implementations. So your sign in with Google, and your sign in with GitHub, and your sign in with Microsoft are going to be just different enough to be annoying, right? So you're going to have to reference the documentation for each one of them instead of having it be standardized. Oh, I just have a library that I can use in my app that'll allow people to sign in with GitHub and Facebook and Microsoft and GitHub or whatever. And so, and Google. And so that's I would say the biggest downside for OAuth is that there's no certification body for it. You can implement OAuth incorrectly, tell the world that you have OAuth implemented, write it in your documentation, and then the app developers just have to deal with it, right? And so that's super annoying, and probably why a lot of people don't like OAuth, because there's no enforcement of how well you've implemented it, and you can tweak stuff, and you can implement parts of it, but not other parts of it. Anyway, so that's probably the biggest downside. Yeah.
So if I want to do what OAuth does, and I don't like OAuth, what other alternatives do I have? Are there other options that are similar to OAuth but are not?
Yeah. So there is SAML. Oh, geez. No, I don't want to solve your damned CAPTCHA.
Bridges.
All the bridges. Is that all the bridges? Sure.
There's always 3 of them in Google.
Always.
No more, no less.
So SAML is actually predates OAuth. It's an XML-based thing, but it's a similar thing where you redirect to an identity provider, and then that redirects back with a signed attestation of what the user is. And so there's not a token flow in the back end. There's just a signed thing, and then you have to cryptographically verify that signature.
So there are people who would prefer to use SAML, and if so, why?
Yes. You prefer to use SAML if you are wanting to charge a lot of money. That's basically where it is, like enterprise stuff, where you're like, oh, this is super complicated. It's identity provisioning and that sort of thing. And like, this is a solved problem in the app world for like amateur programmers for, what is it now, 2006? So that's 17 years, something like that. Like, it's a solved problem that's easy to do, but you want to make it sound hard, it's therefore expensive, and so you use SAML.
But we are in Capital Factory, so.
Yeah, we are in Capital.
They're both secure.
What's that?
They're both secure?
Yeah, both are fine. I would say SAML is much more prone to implementation mistakes because you have to cryptographically verify signatures. And cryptographically verifying signatures, if you don't like put the right parameter, or you mess up and you don't catch an exception or something like that, it's very easy to shoot yourself in the foot when you're verifying signatures over like just token exchange stuff. But it is one less round trip. That's, you know, the benefit of it. Another one is WebAuthn, which is kind of based on it. So web authentication is these things.
YubiKeys.
So YubiKey hardware tokens.
I got one right here.
Yeah. So you don't necessarily have to use a YubiKey or a hardware token. You can. They have updated it now so you can start to use other services. So you can use it like by signing in with Microsoft or signing in with some other identity provider beyond just a hardware token. And so this is kind of, I would say that this is potentially the successor to OAuth, but I don't know. It's kind of shaky. It still involves cryptographic stuff.
Why do you have to have that little piece of hardware?
You don't have to anymore.
Oh.
You can use it with a password manager or something like that. But you have to use it with a password manager is the problem. So, but your password manager can be Google or can be Apple.
For WebAuthn,
Yeah.
my understanding is that that's the goal for.
Yeah. So,
Didn't Google think about going to WebAuthn?
what's that?
Didn't Google talking about using something like this?
So Google uses this for all of their developer and internal stuff. Like you have to use a hardware token like that in order to log into an internal Google developer system.
It's not just developers.
Oh, it's not? Everybody.
There's some
My wife
talk
was a contractor for YouTube TV when we met, and she had a YubiKey.
Okay, there you
There's
go.
some talk now about Google wants everybody to move away from using.
Yeah,
Are you
so
talking
the
about
benefit
passkeys?
of this is it can't be phished because the cryptographic signatures involve the domain that you're on. And so if you're on a phishing domain, like instead of like logging on github.com, you're on github1.com, and you don't notice that, and you log in anyway, your hardware token won't work because it's tied to the domain. It can only be used on github.com. And so it prevents phishing on asking people to make a website that looks like GitHub, but it's on a different domain. And it prevents people from being fooled. But that's like another class of security issue than what OAuth is trying to solve. So, but anyway, that's another type of authentication.
I'm learning a lot tonight.
What's that?
I'm learning a lot tonight.
Hey,
I've
it's
always
been
known they were
useful.
phishing proof, but I didn't know why.
Yeah, it's phishing proof because the attestation for the token you get through WebAuthn is tied to the domain.
Yes.
So do you know about the Identity Workshop?
I didn't know.
Oh, there's a thing called Identity Workshop where they meet all the time. In fact, I think OAuth may have come out of Identity Workshop.
Okay.
It's like an annual meeting or something like that.
Yeah, maybe.
I was just wondering about, but I just wonder if they're working on something
Yeah, I don't know.
like this.
Okay. All right. Keep going on questions.
When they talk about an identity provider,
Yeah.
that would be the OAuth? Like
Correct.
GitHub in this case.
Yeah. So identity provider in this case is Twitter, right? They are providing the identity to the third-party application. But again, that's authentication. That's getting into single sign-on. Like OAuth isn't just single sign-on. Single sign-on is a thing built on OAuth. You can authorize, like OAuth is an authorization protocol, not an authentication protocol. You have to add stuff to make it an authentication protocol.
Okay.
Specifically, you have to add a user info API endpoint to let the user, or like provide information about the user. Otherwise, it's just an authorization protocol to provide an access token to do things like tweet. Okay. Cool.
So it can be a malicious third-party application, try and fake OAuth and get the user to type in their username and password.
Well, I mean, you could do that without OAuth. Like you just create a twitter1.com and make it look like Twitter and try to get a user to fill it in. But that doesn't use OAuth. That's just phishing. So, okay. Well, happy to keep answering questions, but we can also go to the bar. Hopefully this has been educational and has taught you many things about OAuth, and it's been, easy enough through demonstration to show that you can do it too. It's not that scary. You can totally do it. Okay. Thanks, everybody.
Thanks.
All right.
If you wish to view the entire OAuth presentation on the Plutopia News Network YouTube channel, go to youtube.com/@Plutopia News Network. Special thanks to EFF-Austin for providing this presentation. You can stay in touch with Plutopia at plutopia.io. On Facebook, look for @Plutopia News. On Twitter, it's @Plutopia. With John Lebkowsky, I'm Scoop Sweeney. This is the Plutopia News Network, 20 minutes into the future.